Hello everyone. Today we study about how to write algorithm, how to draw flowchart, and how to write program from the given problem statement. So first, algorithm. An algorithm is a finite step-by-step procedure to solve the given problem statement. A graphical representation of the algorithm means flowchart. So now, how to draw flowchart? So first, symbol which is used for the terminal. Use the represent start and end of the flowchart. Second, parallelogram. It is used for input and output. Used for the input and output operations. Next symbol is rectangle. Now the kite. This is used for the decision making. Used to represent the operations in which there are two alternatives, true or false. Means this is used when if else condition is come. Now the arrows, flow lines. Used to indicate flow of logic by the connecting symbols. Now the circle on the page connector, used to join different flow lines. Now we start to write and draw the flowcharts and write the algorithms. So first, the given problem statement is addition of two 8-bit numbers store the result in H register. So now how to write the algorithm? First, get two numbers, because what in the question? Addition of 8-bit numbers. So first we load first number in register B, then load second number in register C. It is up to you which register you want to use to store the 8-bit numbers. So as I told you, algorithm is a step-by-step procedure which follow to solve the given problem statement. So first process is we want to two 8-bit numbers to add them. So that's why we first step is get two numbers and load into the register. Now second, add them. So we know we do not add two register directly. For adding two numbers, one number is move to the accumulator and then we add one register and accumulator. So first copy the register C into the A and then add register B with A. So this is our second step. Now third step, store result. When we add any register with accumulator, the result is stored into the accumulator. Now we want to store result in H register. For that purpose, copy A to H. Means copy the data result A to H and now stop the processing. So in this way we write the algorithm. I hope you understand how to write the algorithm. Now we start to draw flowchart. So first step we know, for the starting and the end of the flowchart we draw a circular rectangle. So that purpose we start the process and that time we use circular rectangle. Then second step, we want to load B and C. This is our input and we know for the input and output we draw a parallelogram. So this is our input. We take 8-bit data into register B and C. So that purpose we draw a parallelogram. Now we want to draw a process. First we copy C into the A, then we add A and B, and then our result we copy from A to H. In this way we do the process and we know for the process we draw a simple rectangle. And now stop the process. For that purpose we again draw a circular rectangle. So always remember, starting and end draw into a circular rectangle. input and output. For that purpose, draw a parallelogram, and for the processes we draw a simple rectangles. So now we start to write the program. So what we want, 2 8-bit data, add them, and result store into the H register. So first we take those 2 8-bit data. For that purpose we write first instruction, move immediately 8-bit data. Suppose we take 8-bit data is 0 5. So this 8-bit data into register B. We take first our 8-bit data into register B. Now we take second register, second 8-bit data. For that purpose again we use instruction move immediately. Second 8-bit data, we assume second 8-bit data is our 06. Into which register we want? C register, because we write algorithm and flowchart for the B and C register. So in the program not change the register again. So after taking 2 8-bit data, now we want to add, and we not add 2 register directly. For that purpose one register we move into the accumulator. So for that purpose again we use instruction move C register into A. Move A comma C means move 8-bit data which store into the C register to the A means accumulator. Now we add. For that purpose we use instruction add B. When we use this instruction, automatically B register and A register means accumulator add, and result store into the accumulator. But we don't want our result into the accumulator. For that purpose again we use move instruction, because we want move accumulator to the data into the H register. So move A into H, move the data of accumulator into the H register. Now the required output we gain. So now stop the program. For that purpose we use halt instruction. In this way we complete our program. Now the second type of question is addition of 8-bit numbers and store the result in 1551 location, but using the following table write the flowchart algorithm and program. In previous question we also want to add to 8-bit data and store the result in H register, but in this question we want to refer this given table and write the program. So first we write the algorithm. For the idea how we refer the given table, first we write algorithm. So first step is load first 8-bit number into the register B, then second 8-bit number into register C. In the given table not mention any register. In the table has only addresses mentioned, so we assume any register. Then second step add the registers. For that purpose one register we copy into the accumulator, and then we add one register and accumulator. So add them. That purpose we write copy register C to A and then add register B to A. And now store the result in location 5051, and last process is stop the processing. Now we think we want load 8-bit data into the register. For that purpose we obviously use the instruction move immediately 8-bit data, but 8-bit data we use from the table. So this we here only mention 8-bit data, and register B. So now the second, again want to load second 8-bit data into register C. So that purpose again we use move immediately instruction C and 8-bit data. Now the second step, copy register C to A. So that purpose we use move instruction, move C to A. Then add B, and then store result in location 5051, and the result is stored into the accumulator. So we use STA instruction, store accumulator, and 16-bit data is given 5051, and then stop means halt for the stop the given process. Now we count how many bytes each instruction has, how many bytes. So first instruction is 2 byte, so we write here 2. First instruction is 2 bytes, second instruction is also 2 byte because 8-bit data with the instruction. Now third is 1 byte instruction, so 1. Second also 1 byte instruction, so 1. Now the given instruction is 3 byte because 16-bit data come with the instruction. This 3 byte instruction and the halt is 1 byte instruction. Now count total how many bytes we want. 2 and 2 4, 5 6, 6 and 3 9, 9 and 1 10. Means total 10 addresses we want to complete the given instruction, and the given instruction is also has a 10 addresses 1 2 3 4 5 6 7 8 9 and 10. So we check our program and our given table is match, means we not do any mistake to write the program. Now we want to use the given table for our 8-bit data and hold the locations. So now we start. First is 2 byte instruction, and we know every 2 byte instruction, first byte is used for the opcode and second byte is used for the data. So now our 8-bit data is 3A and 06 is the opcode. Now second instruction also has a 2 byte. We see in our algorithm first 2 instruction are 2 bytes. So from this assume from the algorithm we understand the first instruction is 2 byte. Now second instruction is also 2 bytes. So first address is used for the opcode and second is used for the data. So second 8-bit data is our now A3. Now next instruction is 1 byte and second also 1 byte. So on this basis we understand the 79 and 80 is opcode of the instructions because those two instructions are the 1 byte. Now the third instruction is 3 byte and last one is 1 byte. So these 3 addresses used for the 3 byte instruction and the last 76 is the opcode of the halt. So 32 is the opcode and 51 and 50 is the data. 51 and 50 is the data. 51 is a lower bit address and 50 is a higher bit address. Now we write using this table, we write the program. Now let's start. We write the program for the given table. Now here at the left hand side I write the program for your better understanding. So first instruction is our move immediately 8-bit data. Now which 8-bit data? 3A is the 8-bit data. 3A to the register B. Now second, we use move immediately because second data we want to move at the C register. So now the second 8-bit data is given here A3. So this A3 move to the C register. Now for the 79 opcode used for move 8-bit data to the accumulator. Any register we use to move into the accumulator. So move, suppose C into the A. So A and C 8-bit data into the A. Now add B. Add B. Now result is stored into the accumulator, but we not want to result into the accumulator. We want result at the location 5051. So that purpose we use instruction sta load store accumulator into 5051 address. And now halt. Now I hope you get the idea about how to write program when the instruction is given into the hex code, and the flowchart as it is start and end right into the circular rectangle, input right into the parallelogram, and the processes right into the simple rectangles. These flowcharts, algorithm and program I provided into the description box. Go and collect them. Thank you.